Hi, I am Judy Madulara and this is my video presentation for Numerical Method Laboratory Plate 6 Activity 2 from, from Lecture 20 Handout Exercises 20.1. So we are tasked to find two tables of data in an engineering textbook or website and plot each data with asterisk as data points, and we're going to decide which best represented if it's either polynomial interpolant, spline interpolant, or least square fit polynomial. And we're going to label the axis and the theta. And so in the MATLAB, I already have this script. We're going to plot the thermodynamics property of water, specifically the pressure and enthalpy of water. This data is from Paris Chemical Engineering Handbook, 8th edition, in Table 2-305, which is the thermodynamic properties of water. So first, we're going to assign x and y values of properties of waters, which x serve as pressure in megapascal here, and y as the enthalpy or kilojoules per mole, and here as you can see in the script. Then the Tn, the formula Tn, which is y plus zero point 0.1 times the rand and size of x. Then we're going to plot the two vectors using period asterisk as the using the asterisk as the symbol in each data point, which is x, the given x, and the Tn, which is the formula given. Then we're going to add labels, adding labels. We're going to add labels for the title, for the x, and for the y. So we are going to run this script so that we can see its plot, and we are going to create the curve. So this is the data points of this, if this data from the Paris Handbook, which is the thermodynamic properties of water, and we are going to find which best fitting for these data points. So first, we're going to click this spline interpolant to see each curve. Then we're go and since it is not scattered, so we are disregarding the least square fitting polynomial. So we're going to choose which degree of polynomial we're going to use for polynomial interpolant. Since we have given data, we have six unknowns, so the degree of it is in fifth degree. So clicking the fifth degree, we have this data. Cannot see it. As you can see here in the line above, the red one serves as the fifth degree polynomial line, which is not that smooth, unlike the spline interpolant. So I think the best suit for these data points is the spline interpolant. So for the table 2, we are going to plot also the thermodynamic properties, but this time we're going to plot for the properties for the oxygen, which is specifically the relationship of temperature and density. It is still from the Paris Chemical Engineering Handbook, 8th edition, table 2-245, which is the thermodynamic properties of oxygen. So first, we're going to put the data values. X as temperature in Kelvin. We have 72 to 120 with this step size of 5, and then its corresponding density in mole per decimeter cube. Then we have this formula TNY plus zero point 0.1 multiplied by rand, and this the size and the x. Then we're going to create another figure window so that we can identify which and differentiate and compare the data from the thermo properties of thermodynamic of water and in the oxygen. So we are going to plot the data value using the asterisk, so this command, and we are going to add the labels for the title, for the x and the y axis. So we're going to run this script. Here is the script of the thermodynamic properties of oxygen, where in the x-axis is the temperature and density for dy. So we are going to choose what's best fit for these data points. So first we are going to see this spline interpolant. As you can see, it has a smooth line connecting all the data points. And since we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 data points, so we are going to identify the 10th degree polynomial. So we have this 10th degree. As you can see, you have this quotient here. Polynomial is badly conditioned. Add points distinct. Select a polynomial with lower degree or selecting center and scale data. So from this legend, the blue line is the spline and the light green is the 10th degree. So for the 10th degree, it is not smooth as the spline interpolant. So it concludes that the spline interpolant is the best fitting for these properties, for these data points, comparing with the term with the data points of water here, and both of them are best fit for spline interpolant. And that would be all. Thank you.